Hello, I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today, I'll be speaking with Joshua Israel, Market Development Manager at HORIBA Automotive Test Systems, about some of the design and engineering tools that the company offers and how it sees that technology being used in the heavy equipment industry. So thank you for joining me today, Joshua.
Yeah, thank you. Thanks for having me.
So maybe if you could talk about what types of test systems the company offers that benefit the testing and development of heavy-duty electric vehicles and equipment.
HORIBA Inc., particularly the Automotive Test Systems division, has historically been known as an emissions testing company, right? That's a big part of our core business. It's a time of almost unprecedented change in the automotive sector, right? And that includes the off-highway space as well. So we've grown our catalog and pivoted to face more of what's commonly called CASE technology, so connected vehicles, autonomous, shared mobility, and electrification of vehicles, which is an enormous space that's always growing right now. So some of that growth has been through acquisition of other companies to offer different services, different products, and some of that is growing the brand organically from our core technologies. So in terms of heavy-duty electrification, we're doing a lot on the mechatronics side, which would be like the development of e-powertrains, right? Our portfolio is kind of expanded so that we can address the needs of customers at every phase along that development chain, from concepts through R&D, all the way to certification and production and beyond, right? So that e-powertrain equipment, particularly our Titan, that's a good product I think you're familiar with, strictly for the development of e-powertrains, right? It's designed from the ground up to address the needs of a company that's developing new powertrains, all the way up to very large e-axles, all the way up to 1.2 megawatts standard, and we can go beyond that. So this is certainly getting into that space where you're covering things like mining, industrial. A good example is we have a big project with the U.S. military that was public, so we're able to talk about it freely, with large freewheel hub dynos, as well as e-powertrain test stands, right? So that's for the development of extremely large vehicles that can see lots of dynamic loading conditions, lots of different environmental conditions, including things like tracked vehicles, which is also very, very common in that off-highway space. Conceptual and early development side, we've acquired a company called FuelCon, which is now HORIBA FuelCon, in the past few years, that their product line is facing the development of batteries at the early stage, right, before they're integrated into a powertrain or a full vehicle, right? So battery testing, battery cycling testing, where you're looking at the lifetime of batteries. They have a big full line of products that are about fuel cells as well, right? So we see that as a growing part of the solution here for electrification is fuel cells. And then another acquisition we've made in the past 5 years has been a company in the UK called Myra, now HORIBA Myra, and they're a big engineering consultancy firm, right? So we offer that kind of development as a service offering now, not simply a product, but part of the solution, as we can sell you the equipment needed to develop your own vehicles and the engineering support needed to help you along the way. And they have an extremely large proving ground that has a wide range of applications, including functional safety, which is a big part of that electrified vehicles initiative, right, is making sure these things are developed and deployed in a safe way. So I like to think we're addressing those solutions all across the board, and I believe we are.
Would you be able to talk a little bit about maybe specifically some of the systems or features, benefits, or how they benefit the development of electric vehicles or equipment, or maybe why choose a HORIBA system for that?
Sure, yeah. So the electrification space, particularly in off-highway electrification, is a really diverse picture, right? I mean, at a very small end, when you talk about very small off-road equipment, you find things that have been electrified for many, many years, right? Particularly when you get into like lawn equipment, when you talk about things like ATVs, even things like golf carts, right? Where we've seen electrification for decades. At the other end of that spectrum is very, very large equipment, some of which, like locomotives, have been electromotive drive for a long time, right? Others are areas that have traditionally always been diesel powertrain, right? Things like mining and industrial, other than a very few niche specialized applications. What we've tried to address is this idea that we want to help companies develop a product all the way from the ground up, right? So you can use a HORIBA product at every stage of that development, right? It's tied through software that can help with workflows. Our enterprise software is something that aids in the development of product development program across its whole life cycle, right? Our battery products help you at very early stages where you're trying to refine and or select batteries unique to your application. As you move into that prototype phase, we have powertrain test stands like the Titan that can be used to develop the powertrain as a standalone, can be adjusted later as people are exploring hybridization to have, an electric, an e-axle, as well as paired with some kind of diesel motor or some kind of diesel as a prime generator of energy that's feeding into an electromotive drive system. And then when you get to the complete full vehicle stage where you're ready to be in production and certification, we have all the products necessary to perform those regulatory driven tests, right? So there's a continuity of using our products across the board that ultimately leads to this gain in efficiency, right? And that's maybe the key selling point that we've been able to engage with our customers with, because now more than ever, they're asked to do more. They have a diversity of products, maybe making a hybrid and an electric and still a traditional internal combustion engine powertrain all at the same time, always being asked to do more with potentially less, with potentially smaller budgets as those resources are being spread into other areas. So in our minds, the reason to buy HORIBA is because we can support you at every step of the way, and those gains are additive, right? So ultimately you have this big net increase in efficiency that helps you get done what you need to get done.
Will the company work directly with an OEM or manufacturer to aid with the testing, or how does that process kind of work?
We do have an engineering consultancy and contract testing wing. I'll say we do work with a multitude of OEMs through that means. Most of the time, non-disclosure agreements prevent me from mentioning them by name or talking about the specific work, right? There's a few instances like the Army where that's a publicly bid project where we're free to speak about things because it's open. But, in general, we work with too many OEMs and tier ones to name, right, as testing partners. And out of our Troy location, which is north of Ann Arbor, we do a lot of testing for those customers, aiding them in the development of, like I mentioned, e-motor test stands, T-rigs, if you're familiar with that technology, right? So we have a lot of capability within that building to perform that testing with them, and through some of our engineering support, actually be in on the engineering and design of those products. At HORIBA Myra, as I mentioned, it's 365 days a year we're doing development for OEM partners there, right? Big advanced battery development suite at Myra. They're always working to help solve common electrification problems, particularly range, right? Range anxiety is a big deal in the electrified vehicle space right now. For off-road equipment, the term range can be deceiving, right? Because those vehicles may not travel very far throughout the course of the day, but they see such high torque loads that it's still extremely draining on the battery to perform the duty cycles that they need to operate on. And we're always doing that kind of work with and for customers.
Well, that kind of leads into the next question then. Are there any challenges you guys have seen associated with testing and developing electric heavy-duty off-road equipment, or what are some ways of maybe overcoming those challenges?
Yeah, for the heavy-duty off-road space, like I mentioned a minute ago, one of the biggest challenges is just that the applications require such high-voltage components, right? You're talking 800 volts or higher, in some cases much higher, because of those extreme duty cycles, right? And extremely high torque limits that these machines need to achieve to accomplish what they need to get done, right? To perform the useful work, that the reason why their customers buy those things, right? So a lot of the challenges that we see are simply, how do we electrify something that has always been traditional internal combustion engine power source, right? And a chemical fuel. So we have a very dense chemical fuel as a source of our energy that can transmit extremely high torque loads and do a great amount of work in a short time, particularly when that vehicle might be stationary and far from a recharging source, right? There's very limited infrastructure. So the big challenge we see are, how are companies overcoming those things, right? As I mentioned, range anxiety is another big part of that, and particularly battery density problems. How do we optimize things so that they can output a lot of energy in a short space without completely depleting the battery? How do you get power back into the battery, optimize those processes as the vehicle moves throughout its time? You see a lot of off-road companies that are starting to do that sort of thing, right? Komatsu has an electric excavator now, CAT has an electric dozer, right? So that there's a lot of electromotive drive work going on that will allow, in the near term, a diesel engine can still be that generator, right? Can still be the energy source while the technology is being developed to feed into those electromotive drive systems from other sources, batteries, fuel cells, et cetera, right? And those are the challenges that are needing to be addressed immediately, right, in the immediate future. That's what a lot of our products are geared to. Those large e-test stands, powertrain rigs, large battery testers, large battery emulators that would allow you to do a lot of this work in the lab. And that's another thing that's been a big area of focus for HORIBA, is this idea of taking real-world performance and being able to simulate and emulate that within a laboratory space, right? So you get a much clearer picture of how your product will perform in its actual real-world use case, but do that testing within a laboratory where you have control over so many more parameters, and the confidence that when you make changes, you understand how those changes will affect performance in the real world. That's another big challenge we're helping our customers address right now.
So how does the company foresee electrification progressing in the coming years in the heavy-duty vehicle and equipment industries? I mean, it seems like it's just on the upward trend. Is that what you guys are seeing? Or
it's easy to imagine a future at some date, right? X number of years out where we live in a wholly electrified world, right? That's what the ultimate end of a lot of those trends say, right? And you start to see some new regulations where they're even putting a date on that, right? California's spark ignited off-road equipment regulation that's starting to mandate by this year, we want all of the small off-road equipment in California to be electric, right? So you're starting to see places put actual dates on that. We believe in that trend, certainly where we see technology going, but we always think that no matter what date you think that point will be, whether it's 2030, 2040, or 2050, when we get to this all-electric space, it's impossible to imagine a time where those technologies don't coexist, right? Where there's some transition between the combustion engine to an all-electrified world, right? And not to mention there's massive amounts of effort needed to be done in the power generation area before we're really all electric too, right? So the grid, we need upgraded power sources from renewables, all of those things, right? So there's so much work to do. And in fact, it's an extremely exciting time. This generation of engineers that are graduating from college now, right? That truly is going to be the work of their generation, is this transition from traditional powertrain sources to an electrified world. Personally, I think that there will always be a niche for some sort of chemical fueled engine, right? I don't think we'll ever see the disappearance of the combustion engine. In the near term, and California tends to be a leader in terms of proposing these things, but I think we'll see electrification in niches where it makes sense, right? In places where electrification, as I mentioned before, has already been, right? In small off-road equipment, and places that make sense like refuse, drayage, things like that, right? Agriculture on small scale, or very local places where those vehicles can be recharged in an efficient manner, right? So in the near term, there's certainly going to be a niche for electrification. I think the things that we look at as indicators when electrification will really take off, right? When you might see an inflection point in the curve of those adoption rates are really driven by two things. One is regulation, as I mentioned, right? So regulation is almost saying you're going to electrify because we're mandating it, right? That's certainly a big indicator, right? The on-road space is where a lot of that is happening now. But as we've seen historically, what happens in the on-road space, it tends to happen in the off-road space just down the road, right? Yes. 7 to 10 years later, you see the exact same thing happen. Yep. What I think, and what we see as a company as the real indicator of when that electrification will take off, will be when it's cost effective to the companies that buy that equipment, right? When the total cost of ownership of, say, an all-electric excavator is cheaper than traditional powertrains, right? That's related to the problems that are faced by electric vehicles in every application, right? It has to do with the cost of batteries, with robust charging infrastructure and lots of things. And as those things continue to trend downward, that's when we see that we'll see wholesale electrification in the off-highway space and other spaces as well. We're part of this community, right? And they're facing unprecedented change, and that change is something we're going along with too, right? So we're excited to pivot with our customers. Ultimately, they will make a decision about where this technology goes, right? So trying to adapt and suit their needs as they change.
Well, thank you very much for joining me today and providing the insight into the technologies and sort of where you guys are seeing the trends going.
Yeah, appreciate it. Thank you.